One, two, three.
We're going to do another example where we're adding vectors together that are given in polar form, and we're assuming that the person doesn't use the cosine rule, or doesn't want to use, or doesn't know the cosine rule. So, because you can use the cosine rule to do this as well. Just gives us a chance to practice the conversions between polar and component form. So the idea of this one would be to convert your polar to component or Cartesian form, and then back to polar, because we're assuming the answer needs to be given in polar form. So that's good practice for us. So we've got vector u and v. So let's convert u now into component form. So remember, component form in a 2D vector is x comma y, usually given in that format, but the formats can vary slightly. Okay, so x, we need to get component x. X is r cos theta, and that would be 10 cos 30 . Now I'm going to use exact values in this video. You can use decimal approximations unless you need the exact value. 10 cos 30 is 10 by root 3 on 2, so we would have 10 over 2 is 5, so we'd have 5 root 3. And the y component for vector u is r sine theta, 10 sine 30, where sine 30 equals a half. So that'll be 5. Alright, so u, vector u, therefore vector u equals 5 root 3, 5. Now we do the same for vector v. So partitioning that off, vector v, again, same process. And there we see the x component, and it's 0, which makes sense when you think about the direction of that vector. Now for the y component, so we've got r sine theta for y, which is 12 sine 90. Sine of 90 is 1, so we have 12, which again makes sense when we consider the vector, if we can imagine what it would look like. Visualization is really important. Okay, so visualization of vectors, draw a diagram if you can, if you need to, because if you drew a diagram of vector v, you would see that it's pointing straight up because of the 90-degree direction. Okay, so it makes a lot of sense. Okay, so now that they're in component form, I guess I better summarize vector v. There it is. So vector v is 0, 12. We need to add u plus v while in component form, which would be 5 root 3 plus 0 and 5 plus 12, which is 5 root 3 plus 17, comma 17 plus, silly, fixed there. Okay, now we've got the sum. We're assuming that it should be reported back in the form that it's given, which is a pretty reasonable assumption. We're going to convert back to polar form. So we're chasing an r comma theta, so we've got an x, y now, and we're chasing an r comma theta, which is the polar form. So converting we need to find r, which is application of Pythagoras' theorem essentially, and we've got 5 root 3 all squared plus 17 squared, and then we take the square root. So 5 root 3 all squared is 5 squared by root 3 squared. Root 3 squared is 3. Plus 17 squared, which we can $289, I knew that. So 75 plus 289 so 19 point, let's say 2 decimal places, 19.08. So we have our magnitude r. So now we find theta. Theta is inverse tan of the relevant y component over the x component. Now these are both positive, so we don't have to worry about locating the acute angle and then finding the true direction, because that'll be in the first quadrant, which makes things easier than they might be. So that'll be the inverse tan of 17 over 5 root 3 into our calculator. Okay, about 63 degrees, 63.0 degrees. So putting it together, u plus v was 19.08. Let's be consistent. Let's just say 1 decimal place in both cases, 19.1 and 63.0 degrees. Make sure you put your degree symbol in so it doesn't look like a component form vector. Like I said, it is also possible to use the cosine rule to do the same thing, and it's a similar length, that process, so I guess it's down to what you prefer, but you do need to know this skill of converting between forms of vectors.